Yeah, my name is Chacon. I am here presenting a paper that's really based on my dissertation as part of a master's on advanced security and digital forensics from Edinburgh Napier University. And I completed this as a part-time distance learner. I really work as a full-time real-time systems integration consultant for Eigen Limited, which has kindly sponsored my dissertation and participation in this conference. So we've titled this paper towards identifying human actions, intent and severity of APT attacks, applying deception techniques and experiment. Okay, so APT attacks, advanced persistent threats or targeted attacks. Let's look at what's that about. These are, very, very sophisticated types of attacks, and they rely on social engineering attack vectors, which are really difficult to prevent. Because they target the human element, which is notoriously difficult to prevent. They also harvest and use zero-day vulnerabilities. That means when you patch your systems, that's not going to help you because a patch has not yet come out. And in reality, it only takes one click for the adversary to get a foothold inside the perimeter, the safety perimeter of the organization. Now, once they are in your organization, they operate very silently. And here are some statistics from 2020, and the average is that these APT attacks remain undetected for up to 56 or an average of 56 days. And actually it only takes them 9 hours to move laterally. That means from the host that they attack to move and infect and move around the organization to another host. So as you can see, it's a very formidable type of adversary that we're talking about here. In these cases, in APT attacks, traditional intrusion detection techniques are not very effective. They use polymorphic software kits, which means signature detection is useless because the signature will change all the time. And they communicate using a variety of stealthy techniques. For example, they send messages as part of DNS packets. Anomaly detection can improve on this, but the problem with anomaly detection or based on machine learning is that they generate a large number of false positives and they can create SOC analyst fatigue. The major attack techniques, tactics and procedures are a promising source of clues to enable APT detection. We didn't go directly into this. But these actions from APTs, once they are inside the organization, are human-driven. They can use a toolkit, they can use tools, but a human needs to examine the results to make decisions of where to go next. So in summary, from APT attacks, we need better and faster detection techniques to be able to catch them sooner. In terms of the deception, we decided for our investigation to investigate deception techniques. Now, the original deception technique is not new. The honeypot is actually over 30 years old. It's been around for a while. However, right now there's a renewed interest in this family of techniques with honey nets and simpler objects called honey tokens. In an earlier presentation, this was called decoy elements. It's the same thing. Also, breadcrumbs is another term. Actually, there are a few commercial offerings. I've found at least 2 commercial offerings that use these techniques, and you can see the references in the paper. A honeypot is basically a real or simulated computer host with no legitimate purpose. So any interaction with a honeypot is immediately flagged as suspicious. That's the basic tenet. Honeypots come as high interaction, medium, or low interaction. High interaction are real computers that allow real logins to be examined for attack behavior. And low interaction honeypots are just basically simulations of a network port enabled, for example, port 22 on SSH. Honey tokens, on the other hand, are digital items with no purpose. They're just essentially things like fake credentials, database entries, things like this. In a prior presentation, there's a whole catalog of this. Also in our paper, there are references. Now, in commercial literature, there's this new term has come about called breadcrumb. And breadcrumb I understand as a honeypot, a honey token that leads to a further decoy or to another honeypot. So honey tokens are much simpler and easier to maintain than honeypots. This is a very interesting feature because when we deploy these devices, we also need to maintain them. So In this area, a few authors have proposed the use of honey tokens for APT or even internal threat detection, but none of them, to our knowledge, have experimentally tested their proposals. A few have even acknowledged this. On the other hand, and this is the topic of the previous presentation, some researchers have focused on detecting bot activity on low or medium interaction honeypots exposed to the internet directly, okay? So they've been focusing on analyzing thousands of attempts. These are not focused on detecting APT activity after a breach because internet exposed services will be targeted by many opportunistic actors, bots, for example, and not necessarily APTs, okay, that's important. Now, these experiments only identify human actions by exception. That means if it was not identified as a robot, then it must be a human. That's the conclusion. Now, the question we asked ourselves is, can it be possible to positively identify human actions and level of intent in obtaining a breach by the use of deception techniques and more specifically, honey tokens? So these are the research questions that we posed. First, can the influence of human reasoning and the interactions be deduced with the use of honey tokens in a honeypots located within the security perimeter? And question 2, can such an arrangement of honey tokens be used to determine the level of intent or severity of the attack? So in summary, we're trying to infer human reasoning and develop the level of intent or commitment to breaching further. I mean, here intent is just to be understood in the standard dictionary sense as, you know, determined to do something. There's a determination. A higher intent will imply a higher severity. Why? Because it implies I'm here determined to take all the actions to breach your system, to exfiltrate data or any other malicious objective. Now, for this experiment, we've selected 3 honey token techniques, and they are an invisible URL link. That means essentially, you know, a link in a web page, which is white on white, so nobody human can see it. A disallowed entry in the robot.txt file. This is used by web crawlers to find out if they should go in this folder or not. Obviously, it can be used for malicious intent. And also fake credentials as comments in the HTML page. These are all from literature, we selected them. Of course, all these honey tokens refer to a login portal, a web portal. So we set up a fake login portal, and we'll talk more about that later. So to test these questions, we set up an experiment involving a volunteer pen tester commissioned to do a penetration test on a certain system. We didn't tell him about the honeypots, obviously. The tester was told that we had a research project observing pen testing techniques, just something very general. Obviously, a proper consent form and pen testing brief was prepared and agreed. This experiment was set up inside Eigen, inside the company, in an OpenStack private cloud environment. And this is the architecture that we set up. Obviously, we have the pen tester is in the internet, in a different location, and a separate VPN was set up to allow the pen tester to access the subnets where the honeypot, the web server honeypot, and the monitoring host were set up. For monitoring, we used the Elastic Stack as a monitoring harness using FileBeat, Logstash, Elastic, and Kibana dashboard to visualize the log events. Also, T-Shark was used to monitor key network traffic traces, which was also monitored by FileBeat. By the way, all of this is open source, it's free, so any researcher can use it, although I would say it's quite challenging to configure. So this is the view of the fake login. It was posing as a user or a client login. And you can see here that the invisible link, you can't see it, but it goes to test login index.php. Here's the robot.txt file with a disallowed entry of admin. And inside the page, here's the comment which says test login user, eigentest1 at eigen with a password E1 arsenal with a 3, right? So that's what we put in there. The way this works is, you know, people try to log in and there's a simulated delay and the system tells you, sorry, error in credentials, try again, and it's invited to try again. It's completely fake login and won't take you anywhere. On the comments, on the comment honey token, there's an added original feature because as you can see here, the email is incomplete. And so this is inviting the user to complete the email as eigen.co, any other option they might think of, right? So here we have a view of the Kibana dashboard used to monitor this. It is showing from left to right pings to the honeypot here, access to the index PHP. So this is the main login page, the number of clicks on the invisible link. And at the bottom, you have a inward or outward TCP SYN packets. So from the network, obviously that means some sort of level of interaction with the honeypot. Also the login attempts with the login credentials. And finally, the number of access to the disallowed folder /admin, okay? The experiment ran for about 1.5 hours. And so we monitor the progress of the pen test by recording the session in this Kibana dashboard and then analyzing the results. Obviously, in an industrial setup, there would be alerts configured to the SOC. It's not practical to look at a screen. So we classified observations in 3 priority categories. We said low priority, if there's any level of network detected interactions with the honeypot, or the use of automatic reconnaissance tools with minimal human reasoning. And these are indications that the attacker reconnaissance activity and the start of an attack. For us, that's low priority. Something's happening. We don't know if it's opportunistic or if, on the other hand, if it's a real APT attack. Medium priority is the result of reconnaissance, is if the result of reconnaissance was used to take the intrusion further and attempt a breach, with some possible human actions, some initial human actions, or automatic tools, the use of automated tools. High priority indicators would be if a honey token was discovered by a human actor, and then we can detect further human reasoning to expand the efforts leading to a breach. For example, if the information found in one honey token, and this we would call it a breadcrumb, was used in a subsequent step, indicating a high level of intent. A prior presentation actually explored this whole topic, in a lot of detail, going from one honey token to another, etc. It's quite interesting. So these were the results of our experiment, shown as a state diagram. We start from the beginning with very low priority indicators, basically basic recon, as you would do when somebody's trying to attack you. Typical tools. From that, the attacker moved into automatic web app scanning tools and finally discovered the login page. At this point, we move into medium priority. The /admin folder was discovered quite quickly, and this was discovered by a tool called DIRB. We'll talk about that later. But at this point, from the login page, we have the first human attempts because we can see very low frequency and type in different random login credentials. And the invisible link also was found by Burp Suite from the automatic web scanning, but this was found much later in the whole process. Now, from the first human attempts, then we find the first indication of a high priority indicator because the fake credentials planted as comments were used. Not only that, but after that, there were variations on the credentials. And finally, those credentials were used to set up Hydra for a brute force attack using the fake username and a whole password dictionary of passwords. And finally, the test concluded. The problem with the disallowed entry was that it was found by a tool called DIRB, which uses a tool called fuzzing, which basically tries to guess folder names. Since /admin is a very common folder name, it found it immediately. So bad choice, but it leads to a recommendation. And here are some samples from Kibana, which you can graph the time signal of the attack. On the left, you can see the manual login attempts. You can see the scale on the left. I don't know if you can see it, but the count is 0, 2, 4, 6. Very low number of attempts per minute. as compared to the brute force attack on the right. And you can see here, it's trying with the credentials eigentest 1 at eigen with a whole host of passwords. And you can see here, the frequencies are in the order of 200, 500, etc. Okay, so definitely a tool we found from the pen tester. It is Hydra, but obviously configured by a human based on human reasoning. So by far, the most successful of the honeypots that we tried was the fake login credentials. This is a very interesting, but limited observation, but it's what we found from our experiment. So for future work, in this limited experiment, we definitely observed an increase in human reasoning and actions as the pen test progressed. By far, as I've said, the most effective technique was the use of fake credentials. The least effective was the disallowed entry in robot.txt file. Again, because as I said, the name is very common and it was just guessed. So the recommendation from this is that we should use non-common names in all honey tokens of this type. So they are discovered and analyzed as intended and not as a wild guess, okay? And that happened with the invisible link. The invisible link name was not in any dictionary and had to be found. When it was found, we found it was found the proper way, the way we intended. Furthermore, we could allow, and this is, goes to the progression of what was called in the previous presentation, the rabbit hole. We could allow some of these fake credentials to initiate some sessions, maybe in some medium interaction honeypots, and actually we could study the actions of the adversary from that point onwards. This is a very interesting, area of research, and the way we can link the different honey tokens together and to kind of trap the adversary into a rabbit hole, as our colleagues presented. An ambitious future project would see the setup of a completely fake company in the cloud with fake employee avatars, with LinkedIn accounts and social presence, and put this out there and allow to test these concepts completely in the wild. So with real attackers trying to hack. So finally, some acknowledgements to Charlie Josier. Juanjo Mata was the blind pen tester. Very grateful to him. Rustem Gafurov, Steve Jones, Vicente Fontanelle, and all my colleagues at Eigen, and my wife, Mayret. Okay, so I will take questions now if you have any.
Yeah, thanks, Joel. So we have a couple of questions already. So the first one is, did you only use a web/HTTP as honey token?
Yes, the honeypot was effectively a web server, yes. And all the honey tokens are essentially, yes, they are suitable to be deployed in a web server. So that's the reason we selected that. I must mention another requirement of my dissertation, not necessarily the paper, but of my dissertation, is that all the honey tokens would be self-contained, okay? So there were a lot of ideas for honey tokens that were distributed. For example, fake DNS entries. Okay, that would have to be configured in the DNS server. And so I was trying to use or select honey tokens that were self-contained within a thing, right?
Okay, and then Josh is asking, were you using actual human subject in this study, or was everything computer generated? And if you were using human subject, what was your sample size?
Yeah, good question. It's a real person, I can assure you. I've met him. His name is Juanjo Mata. He's right there. So it was a real human pen tester. So no simulations. This is we didn't see any experiments in literature. So this was one of the things that was, we thought, quite original. In terms of number of samples, sorry, but just one. It was quite challenging to find, pen testers in a volunteer fashion. Obviously, another research could do this with kind of paid pen testers. Yeah, absolutely.
Yeah, we always need incentives, don't we? Okay, let's see. There is another question, a couple of questions here. So regarding the ethical aspects of using deception, I have two questions. One, did you have any challenges with obtaining permission from your institution? And two, what challenges would you foresee in using deception technologies in live production environments?
Yeah, great. Yes, lots of challenges. Essentially, the original intent was to get, actually, the original intent was to expose this web server to the internet. And once we reviewed the risks of that, it was a massive no. Okay, so at that point we decided, okay, let's put it on the inside. And then we started the requirements for the company to allow me to run this experiment was to set up a completely separate VPN and allowing the pen tester to come in. There were essentially no ethical aspects. I mean, considered at that point, it was more about security. Because obviously it was an experiment using my own data. There was nothing also that the pen tester could steal. Obviously, the agreements were made and signed, of course. In terms of deception challenges for production environments, I think it's totally applicable. There are a couple of commercial offerings out there. One is Elusive Networks. I think it was called Altiva Networks. You can check them out. They're being offered commercially. In terms of ethical considerations, you can find in the paper one reference of somebody that studied this.
And then we have more suggestion from Shreyas. The suggestion is you can also open up the honeypot to attract internal attacks, given that you are in an enterprise network.
Yeah, totally. I think these type of honeypots and honey token techniques, once they're inside, obviously, if they are getting attacked, you have two options. It's either an adversary that has gained control inside your network, or it's an insider attack. And that's, you know, up for analysis, you know. Obviously, if the attack can be detected from what account the attack is coming from, we can then investigate that attack. Has that account been compromised, or is it the same? You know, employee that's attacking?